Let's take a stroll down memory lane and look at the laws of exponents. If you recall, when you have an exponent here, that really means how many copies of that base that you would like to have. So x squared is really saying x times x. And then when you increase that exponent, it's saying I want 4 copies of my base. And so that's really multiplying that 4 times by itself. We use this idea when we're working with laws of exponents. A lot of students have difficulty with the idea of adding versus multiplying exponents and when do you do each. So let's deconstruct this multiplication. First, x squared times x cubed. Well, x squared is x times x, and that's multiplied by x cubed, which is x times x times x. Remember, the exponent is saying how many copies. Well, we've got 1, 2, 3, 4, 5 copies of the x, so that's just x to the 5th. And if you notice, that's really x to the 2 plus 3. So when you have 2 bases that are like multiplied together, you can just add their exponents to get x to the 5th as your final solution. Now what happens when you have it raised to a power? Well, let's do that outer power first. And so this is saying take 3 copies of what's inside. So we want x squared times x squared times x squared. Oh, that's a 2, not an x. Try that again. We want x squared times x squared times x squared. And we know from this example over here that we can just add the exponents together, so we don't have to write out everything that each of those bases mean here. Instead, we can just add 2 plus 2 plus 2, which is 6, x to the 6. And so we can do that by deconstructing this exponent. Now, what does the 6 represent? It really represents 2 times 3. So when you have a superpower here where the power is on the outside, it's telling you to multiply the outer exponent times the inner exponent. So the parentheses here with the power on the outside gives this guy superpowers. And superpowers means he can multiply in. Whereas over here, no superpowers, you're just going to have to add. Now let's take a look at what happens when we are looking at one base to the next with increasing powers. So for each of these, 2 to the 3rd times 2 gives you 2 to the 4th, where the 3 plus the 1 equals the 4. We can do that again here, where 2 to the 4th times 2 to the 1st is giving you 4 plus 1, which is 5. So when you're going in this direction, you are really adding 1 to the exponent. Now let's go in the other direction. What if we were doing 2 to the 5th, going to 2 to the 4th, going to 2 to the 3rd? For each of these, when you go in this direction, 2 to the 5th divided by 2 allows you to divide out one of the 2 powers. So we're really dividing by 2. And then here again, for the next leap, we are dividing by 2. And you keep doing that as you go down in power. And so down in power is really like dividing by that base, where you get to divide out one power of that base to then just get the next lower power here. We're going to use that idea of going down through a table as dividing by the base and going up through a table of increasing exponents as multiplying by the base. Let's take a look. When you have 2 cubed is 8. 2 to the 4th is 4. And going from here to here, we are dividing by 2. So if we divide by 2 again, we're going to get 2, which is 2 to the 1st. Divide by 2 again, 2 divided by 2 is just 1. 1 divided by 2 is 1/2. And if we do that again, you get 1 over 4, which is really 1 over 2 squared. And then for the next one, divide by 2, you get 1 over 8, and that's really 1 over 2 cubed. And so what you see happening when you have a negative exponent, you get 1 over that base raised to change the sign of the exponent, or a positive 3. Here, 2 to the negative 2 means put that in the denominator and make the exponent positive. Here, you get 1 over 2 to the first, which is really just 1 over 2. So 2 things to note here. First, negative exponents. Negative exponents means you're going to move it within the fraction and put it in the opposite portion of the fraction to make that exponent positive. When you've got a 0 exponent, that means that you end up with 2 to whatever. 0 is 1. If you had 4 to the 0, you'd have 1. And it's because of this dividing action. Now we also can multiply on the way out. 1 over 2 to the third multiplied by 2, you get 1 over 2 squared. Multiply by 2, 1 over 2. Multiply by 2, you get 1. Multiply by 2, you get 2. Multiply by 2, you get 4. Multiply by 2, you get 8. So going down, you're dividing by the base, and going up, you're multiplying. The only reason why we do this table and why we're taking a look at this is because of negative exponents and this idea of a 0 exponent. Let's put that into practice now. 4 to the negative 1 is saying the 4 needs to go into the denominator, and it would have an exponent of positive 1, but we know that the positive 1 exponent is just like having the base that you have here. 1x to the negative 3 gives you 1 over x cubed. Now what happens in this one, you've got a 2 that does not have an exponent and an x that has a negative exponent. So let's rewrite that so it's a little easier for you to see what happens with each piece. The 2 does not have an exponent, so it comes along for the ride. The x to the negative 2, that's negative. We're going to put the x in the denominator, so 1 over that value, and the exponent becomes positive. This then gives you 2 times 1 over x squared, which is really 2 over x squared. Now, we could just take this guy, and from the very beginning, the 2 stays where it is because it's got a positive exponent. The x has a negative exponent, so we're going to move it to the denominator and make the exponent positive. Because now it's much happier, it's where it wants to be. Instead of being here in the numerator, which this is really over 1, we're going to move it to the denominator here, and then it becomes happy. Therefore positive. We can do multiple terms within any single fraction or rational expression. So here, we draw a fraction bar. The 2 has an exponent of 1. It's positive, so it's going to stay where it is. The x has an exponent of negative 1, so we're going to move it to the denominator and make that exponent positive, which is a positive 1, but you don't really have to have that. You can just say that it is x and the 1 is understood. Now in the denominator you have a y to the second power that is positive, so we're going to leave it where it is. And that's it. You're done. Here's one for you to try. So please pause the video, write this, write that fraction down. When you write the fraction down, then go ahead and move terms within that fraction to decide where they need to go. When you're done, hit play and you can check your solution. So let's walk through the solution. 2 to the negative 2, that's a negative exponent, so the base is moving down to the denominator and the exponent becomes positive. X to the negative 1, negative exponent, base moves to the denominator, has an exponent of 1. You don't not have to write that at this point, you can just say x here. Go to the denominator, y to the negative 2. Negative exponent means it wants to move within the fraction to the numerator, so we move it here and the exponent becomes positive. W has a known exponent of 1. Remember, when we have a 1, we don't write it. And so here that is positive, so it stays where it is. So whether you wrote the 1 or not, you can have that here, but here you have to not write the 1 and just have it be as assumed. But the 2 squared needs to become 4. So whenever you have got numbers as bases, you have got to apply the exponent and write the actual number. So when you're on MyLabs Plus and you're looking to write the answer, it is always going to ask you for any numerical bases, the exponents to be applied, and for you to actually write the actual number there. So that's it. Hope you're having a great day.